Hello, geometry students. So today we are going to be doing our last section of notes for chapter 1, and we're going to just be kind of broadly going over perimeter, circumference, and area. So today I would like for you to be able to calculate those three things based off of different pieces of information that you're given, as well as based off of whatever type of problem you have. So first, let's define the difference between perimeter and area. Perimeter is the distance around a shape. That's different than area. Area is the amount of flat space that a shape takes up. Alrighty, so we do have a couple formulas to cover with you. So we have the formulas for a rectangle, square, and triangle. If we consider things to be labeled like we do in these images, that's how these formulas are going to work. If you have an image that is labeled with different letters, then your formula will use those letters instead. But this is it's the same thing. I'm just using L and W for length and width in the rectangle, and so on and so forth. So the perimeter of a rectangle is going to be 2 times the length plus 2 times the width, while the area is just length times width. The formula for a square, because we know that all 4 sides of a square are the same, we are just calling it S. So the perimeter is going to be 4 times S, just S added up 4 times. So we have 4S, while the area, you can write it as S times S or S squared. Both are correct, S times S or S squared. And finally, for a triangle, the perimeter, because we have these labeled A, B, and C, I'll just say it's A plus B plus C, because remember, perimeter is just the distance around a shape. The area is going to equal 1/2 the base times the height. So here we have the height drawn in, and B, fortunately, it corresponds with B for base and B for that side length. If you have the same letter used multiple times in an image, make sure you know what it is representing when, because if you substitute the wrong thing in, then obviously you'll get the wrong answer. So just be mindful of your images and what letter you're using to represent what. All right, next I have this thing. It says important with an exclamation point. I am going to highlight it because it is that important. The height of a figure must always be, every single time for any calculations, the height of a figure is perpendicular to the base. So notice here in this image we had height, and then we had this little 90-degree angle drawn in, and that was letting us know, yes, this line is perpendicular or at a 90-degree angle to the base. Okay, let's do a couple of examples. And it says find the perimeter and area of each figure. So be mindful that it's asking us for 2 things. And we're just going to apply our formulas here. So this one is a rectangle, so perimeter formula is equal to 2 times the length plus 2 times the width. So we're just going to substitute those things in. The perimeter is going to equal 2 times 6 plus 2 times 4, which is equal to 12 plus 8. So the perimeter is equal to 20. Area is just length times width, so that's going to be 6 times 4. So the area is going to equal 24. For this one, let me move that up a little bit. Alrighty. For the next one, don't let the variables in here throw you off. We're going to work it the same way. We might not get just a single numeric value for this, but that's okay. We can still get an algebraic expression, and it's still the solution based off of the information that we're given. So don't let different things throw you off. Still apply the same formula that you would in any other case. So first of all, the perimeter is going to equal all of the sides put together. I'll label them just so we can see. I'll say A, B, and C. So we need to say A plus B plus C for our perimeter. So the perimeter is going to equal x plus 4, which is A, plus B, which is 6, plus C, which is 5x. Now, I am able to simplify this a little bit because I have some like terms. So I will go ahead and do that. Perimeter is equal to x and 5x can be combined to get me 6x. And then 4 and 6 can be combined to get me 10. So I have 6x plus 10, and then I'm going to leave it right there like that, because I can't go any further unless I were given more information. Okay. Now for the area. Area is equal to 1/2 base times the height. So our base is simple enough. It's 6. Our height is the line that's perpendicular to the base. So that's x plus 4. That's what I'm going to substitute in. So I have area is equal to 1/2 6 times x plus 4. Okay. Now I'm just going to solve using order of operations, and I can't combine x plus 4, so now moving on to multiplication. 1/2 times 6 is 3, so area is equal to 3 times x plus 4. And I'll go ahead and do the distributive property here, and that is going to get me area is equal to 3x plus 12. So once again, I can't really go any further than this, so I'm going to leave it at that. Flipping your paper over, we have a couple word problems now. I know everybody's favorite, but practice makes perfect. So here it says, the Queen's quilt block includes 12 blue triangles. The base and height of each triangle are about 4 inches. Find the approximate amount of fabric used to make the 12 triangles. All right, so we need to know kind of a couple fundamental pieces of information from this. First of all, we have 12 blue triangles. That's important. We're also told the base and height of each of the triangles that are going to be used. It's about 4 inches. So I'm going to draw a quick little image. And I don't know if this is exactly how the triangles looked, but I do know the base and I do know the height, so that's all that matters. I have 4 for the base and 4 for the height. Perfect. Find the approximate amount of fabric used to make the 12 triangles. So what we can do, if we can find the area of one triangle, then we can find the area of 12 triangles. So area of one triangle. So the area is going to equal 1/2 the base times the height, which we have that from our word problem. So area is equal to 1/2 of 4 times 4, which is going to be about 8. I say about because it said approximately, so we're just kind of estimating this based off of these words. But we're going to be very close. So the area of just one is 8. The area of 12 triangles is going to be the area of 1, which is 8, multiplied by 12, which is going to get us 96. To put our unit on there, notice it's inches, so 96 inches, but we want to say squared because area takes up square space. So it's 2 dimensions that it's taking up. So I'm just going to say 96 inches squared for my final answer. Alrighty. Moving on, In example 3, it says find the circumference and area of a circle with radius 8 centimeters. First, write the exact answer in terms of pi, then use the pi key on your calculator and round the answer to the nearest tenth. Okay, so when we say leave something in terms of pi, it means that we're just going to keep writing the symbol and not multiply it out, because that can give us a very precise solution. We have our formulas right here. Area is equal to pi r squared, and the circumference is equal to 2 pi r. If you can't remember what circumference is like perimeter, but it's the length around the circle. So circumference is length around the circle. R represents radius. Radius is halfway across the circle. So I'll write that in. The radius is halfway across the circle. So we are given all the information that we need to solve this. It says radius is equal to 8 centimeters, and we are finding the circumference and area. So circumference first is going to be 2 pi r. Well, I have my r right here, so it's going to be 8 centimeters, and I'm just going to substitute that in for r. So now I have 2 pi times 8, which is equal to 16 pi. This is how we leave our answer in terms of pi. So I'm just going to circle that. Now, to get it into an approximate answer, you're just going to type into your calculator 16 times, and then you're going to hit the pi key on your calculator. When you do that, you're going to get the number 50.3. I'm only rounding to 1 decimal place because it said round to the nearest tenth in the directions. So make sure you're paying attention to that, because as you guys have noticed, for your online homework, the website is pretty picky about whether or not you're following directions for how to input your answer. So we just took care of the circumference. Now we need to take care of the area, but we're just using this second formula, and we're going to apply our knowledge the same way. So the area is equal to pi r squared. Well, let's substitute that in. So we have pi times 8 squared. It's not the pi and the 8 that's squared, it's only the 8. So now this is going to get us 64 pi, because 8 times 8 is 64, and then I'm leaving the pi symbol on there for my exact answer. To get my approximate answer, I need to type into my calculator 64 times pi, which is going to get us about 201.1. Alrighty. We have one more problem for today's notes, and it says, what is the area of the given figure? Well, notice how this is not a typical shape like what we're used to, but we can break it down into 2 shapes that we know and are familiar with. So I'm just going to draw a dotted line here. I'm going to put in a 90-degree angle symbol so we can tell that I'm drawing that perpendicularly. And what I can do, I can take the area of this rectangle plus the area of this triangle to get the total. So I'll do the area of the rectangle first. So area is equal to length times width. So the area is going to equal 14 times 18, which is equal to, I did this over to the side already, so that's going to be 252. Okay. That's important. This is not my final answer though, because I want the area of the whole shape. So don't stop when you've only done half of the problem. Keep going. Okay, now I need to find the area of the triangle. Well, I know area is equal to 1/2 base times height. I'm going to say that this part up here is my base and this part right here is my height, because these two sides are perpendicular to each other. it's okay that it seems upside down, because as long as my base and my height are perpendicular, I'll still get the right answer. Orientation does not change the area of something. So I need to figure out how far it is from this point to this point. So I'll highlight so you can kind of see what I'm trying to calculate. Okay, so I know based off of the bottom that from here to here is 14. What I can do is my segment addition postulate, where I know two segments added together get me the total. So if I already know the total is 20 and part of it is 14, then that means this remainder right here must be 6. I'm going to do that same strategy for this part, and I'll label that height one more time just so you guys know that. And I'm trying to calculate the part highlighted in yellow. So I know the total length is going to be 18 based off of this information right here. So 11 plus what is going to get me to 18? Well, 7. So now I have my base and height of the triangle, and I'm going to substitute them into my formula. So area is equal to 1/2 the base, which is 6, times the height, which is 7. That's going to be 3 times 7. Area is equal to 21. Okay, to get my final result, to get the total area, I'm going to take these two values and add them up. So I have 252 plus 21, and that is going to get me 273. Now I'm looking at my units, so I'm going to say meters because we have an m right here, meters squared. Alrighty, that's it for today's notes. Hopefully that was making sense. Of course, per usual, you're able to ask me questions in class tomorrow, but until then, have a great evening.